Yeah, good day to all. Let us continue with orthographic projection, and we'll start with some complex objects today. We'll learn how to project a complex object on multiple planes. So let us try to understand a small example. Suppose this is a semicircular object, as you can see here. Okay, so let me try to draw a semicircular object. Yeah, it's okay. So this part I will darken it. Okay. Now, so this is the semicircular object over here, and assume that the observer is standing on this side, X. Let me make a small cutout on this semicircular portion like this. So we'll try to make a small cutout. Yeah, so I've cut the cylinder from the top part. So that is how the cylinder appears like after you cut it somewhat. Okay. So now if you try to draw the front view of this semi-cylinder, the front view is always drawn above, as we know that. So one might end up with drawing a semicircle like this. So semicircle is the front view of this object. So in the front surface you can see this surface as a semicircle. That is what I have drawn here. Assume that the center of the semicircle is somewhere here. So you may draw at least one axis line vertical, center line vertical. Horizontal center line will overlap, so you need not draw here, but at least something can be drawn beyond this. So this is nothing but the center of the semicircle. Now talking about the hidden lines, if you look in the front view, you cannot see this cutout. Suppose this cutout is say 8 millimeter deep. How much? 8 millimeter. We know that in engineering graphics, while drawing orthographic, if there is any hidden surface, you need to represent that by showing hidden lines. So here this surface, which is an arc of a sector, is the hidden surface. If you carefully compress the object like a sponge from this side, then you cannot see this arc of the sector. So if you look at the arc of the sector, the arc over here, it overlaps with this front arc. So if an edge overlaps with the front edge, there is no chance of drawing hidden line on that dark edge. So if I ask you to draw hidden line on the dark edge, it is meaningless. So you can't draw. But this horizontal edge cannot be seen from the front. Okay, its length is not mentioned, but it is mentioned that this edge is 8 millimeter from the topmost boundary of the semicircle. So from here, if you come down by 8 and if you draw broken line, then it is very clear that this surface, the above surface, represents the hidden surface. So that is how the hidden surface is drawn as a line. So in this diagram, when you draw the hidden line, you need to come from the top portion by 8 millimeter down and draw a horizontal line, double trace, to cut the semicircular portion. So the length of this line can be determined only after drawing a horizontal line so as to cut the semicircle. So wherever this line intersects the semicircle, that length is same as this edge. So there are many things in engineering graphics which can be understood only after you draw. You cannot apply mathematics over here. So that is how the front view is ready. Now let us try to visualize the top view of this. So starting step by step, let us start with this semicircular edge. So in the top view, this semicircular edge will be seen as a straight line. So when I project this up, let us try to project this up. Yeah, so when I project this up, you can see a line over here. So this line what I've drawn just now, it represents the semicircular edge. Apart from this, you can also see the bottom edge of the enclosing the semicircle on both the sides. So from here you can see the bottom edge of the semicircle which is enclosed from both the sides. Apart from that, you can see the rear semicircular edge. So that rear semicircular edge will also be seen as a line. So I can draw only partially over here. So I can draw that part over here. So this portion what I've drawn is the semicircular surface, that is this part. Now you can see one more thing. You can see surface A also as a flat surface. So how will you get the length of the surface? Or you can say that in the top view, this semicircular edge will be seen as a straight line. Have you understood one important thing, that this length is equal to diameter of the semicircle, whereas this length from here to here, it is not equal to diameter, it is less than that, because this edge doesn't correspond to the bottommost edge of the semicircle, it is slightly above. So because of this radial gap, this length has decreased somewhat. Okay, so let us try to visualize and draw the top view. So if you look at this diagram from top, and if you project parallel rays of light, because orthographic is all about projecting parallel rays of light, so you need to transfer this down and you need to darken this. So that is how we have darkened this one. So this is the outer boundary of the semicircle, what can be seen. So this outer boundary resembles a semicircular edge, the bottom straight edge, again semicircular edge, and straight edge on the other side. Now we need to draw surface A. So what you do is that from the front view, try to recognize where is surface A over here. So in the front view, that surface A represents this hidden line. This hidden line itself is A, if you carefully observe. So over here, this hidden length is nothing but A. So when you look in the top view, this hidden edge is seen as a surface from the top, and this hidden edge cuts the semicircle at these 2 points, right? So if I want to determine the length of the semicircle, I can find out very easily by understanding that this semicircle or this straight line cuts the semicircle at 2 different points. So if I identify those 2 points and if I project this down, so I'll get 2 separate lines, as you can see here. Now suppose assume that this dimension is say 15, and the in between, this is the slot or the cutout, this is the slot or the cutout, that is 20 millimeter. So from the top view, if you observe, see front view is here. So if you observe from top view, to top view to look from this side, you have to first leave 15 and then 20. So same thing here, first leave 15, draw a line, then leave 20, draw one more line, and when you darken this portion, the in between rectangle what you can see, that is your surface A. So the inner and outer rectangle are not connected. They are not connected because if you look at this diagram, the surface A is not connected to the outer one. So that is how this portion is understood. Can you understand one more thing, that if the hidden line is transferred a bit down, what is going to happen is the length of this line will increase. So if the length of the line increases, the gap between both the vertical line decreases, because as you move this down, this will broaden slightly. So the gap between these 2 vertical lines, what I was shading right just now, what I shaded just now. So the gap between the 2 vertical lines, if you try to observe, this is the first line, this is the second line. This gap resembles a circular surface. It is nothing but a circular surface and not a flat surface. So you need to visualize that this is the circular surface, and in between this A, that is the flat surface. Finally, as we discussed before, whenever you draw a rectangle and if it is a curved surface, you need to represent an axis line. So try to understand, in this diagram the axis line will move inside, because if this was a full circle, then axis was been this one. Now it is a semicircle, so the axis still remains there. So over here we need to show axis line big dash and small dash. This represents that it's a curved surface. Now the doubt is, The middle portion is not curved, then why we are showing axis? So the answer is, look at this diagram. The axis passes below the flat surface A. It is existing throughout. Because of this flat surface, there is no disturbance in the axis. It is still existing throughout. So therefore you have to show axis throughout over here. So these are the two views of a cut cylinder. Yeah, so let us start with one of the complex questions in orthographic, because we need to raise our level till this numerical, or not numerical, till this object. We should be able to visualize this. So first of all, what they've asked us to draw. So they have asked us to draw the front view of the object. So they understood that front view should be along x. So here direction x is being mentioned. So front view is along x direction. Then you have to draw top view and corresponding left hand side view. So you should be thorough that left hand side is always drawn on the right. So let us look at the overall object and understand the consequences of the object, how it is. So if you look at this semicircular part, it is the same thing what we discussed just now. So you can see there is a semicircle of radius 15 and the width of the semicircle is 50. Then there is a cutout which is 8 mm deep and 20 mm wide, and that is left 15 from here. So hope the above part of the object is clear. After that, if you stand in the front position along x, you'll understand that if you look at this line, or if I keep a scale over here, so you'll realize one thing, that in the front direction the object is symmetrical about this vertical line. It is same on both the sides. If you look at the shape, there is a cutout on the left side, same cutout is there on the right side also. So in the photograph it is not very clear what is there on the other side, but whenever you find such kind of similarities on the left and the right side, you have to assume that the object is symmetrical and the same cutout exists on the other side also. That will be your assumption. So always you have to assume like that if it is symmetrical. So now we can see that at the bottom there is a semicircular cavity of radius 22. So our first job is to decide the maximum length, maximum height and maximum width of the object. So maximum length of the object is around 90 mm, 90. You can see that very clearly. 90 is the length of the object. Then height of the object from here, it is 70. See, this height is 70 and that 70 is still the center of the semicircle. So don't by mistake take the total height of the object as 70, because you need to add radius 15 further. So 70 plus 15 is 85. So height of the object is 85, length is 90 and width is 50. So we'll first of all try to draw the three box within which we have to draw front view, top view and left hand side view. So let us write down the length, width and height of the object. So length of the object is 90. It's given 90 over here along x. Height of the object is, if you carefully observe, from the bottom edge it is 70 till the shoulder and you have to add 15 more. So height is 70 plus 15 is 85. And width of the object w is 50. So width is 50. So these are the three dimensions of the object for which we need to prepare box. So let us start preparing the box. So first of all, proper planning is required. I will occupy my front view within this area. So front view has to be here. Then exactly below front view, I will draw top view over here. And because they have asked left hand side view, we should know that left hand side is always drawn to the right of the front view. So to the right of the front view, left hand side will be somewhere here. Okay, so based on that, let me first draw a light vertical line. So I drawn a light vertical line over here. Yeah, so once the vertical line is ready, I will draw a perpendicular line from here let me draw a perpendicular line. So I've drawn two lines perpendicular to each other. Hope all of you can see that line. Okay. Now length of the object is 90. So I need to reserve space for my front view diagram. And front view means you can see two parameters, length and height. So length is how much? 90. So let me mark 90 either by a scale or by rule and draw. So I'll mark 90 over here. And height is 85. So from here I will mark height as 85. Now let me draw parallel lines in connection to this. So here I'll align the roller scale with the previously drawn line. I'll raise by 0.5 or 1 degree. I will roll it down and I will draw a light line. So that is how light line is drawn, but I need to little bit lengthen it. So I will make use of a bigger size scale and I will extend it a bit. Now I need to draw vertical line from here. So for that, align the roller scale with the previously drawn line. Okay, then we can roll, come back. Okay, once again I need to verify. So from here, roll a little and draw a light vertical line, as you can see here. Okay, so I have drawn the box for the front view, which is ready over here. Now the gap between the two views is always standard, what we keep it as 20 millimeter always. So let us keep 20. So we have kept 20 over here, and then comes the width of the object, which is 50. So from here I will measure W50, and we are supposed to draw parallel lines from those marked points. So from here, lift, roll, and from 20 draw a light line. Again lift, roll, and from 50 draw one more light line. Okay, so once these light lines are ready, you can see that this is the front view box, this is the gap between the views, and this is the top view box. So from the corner of the front view box, that is from this corner, I need to draw 45-degree line downward on the right side so that I can project and complete the side view box. For that I need a protractor. So here I can align the protractor and we'll mark 45-degree here. And from this point I'll connect it with the bottom corner of the front view box and draw medium dark 45-degree line. So wherever this width of the object, you can see that this is the width of the object, wherever it intersects 45-degree line, even if you don't highlight, it's okay. So that those 2 points you need to project it up. Okay, so by means of roll and draw, I will align with the side lines. I will lift a little and let me draw a light line like this. Then further one more light line. So that is how the three boxes are ready. This is the side view box which I have drawn without measurement. So only with the help of 45-degree line I can easily complete the side view box. Okay, so let us now start with this particular question. So if you look at this question, you can see there are two semicircles, one over here of radius 15 and second is radius 22. So because both the semicircles can be seen as a semicircle from the front view, it is advisable to start with the front view, and that too you can see that both the semicircles are symmetrical about the vertical line. So the entire object, see the left half is symmetrical with the right half. So the smart work is that first let us why not try to develop a line of symmetry and then copy one half of the object automatically and easily you can draw the next half. So the vertical line will be half of 90, that is 45. So if you look at the diagram over here, we have already drawn a rectangle of length 90. So if I mark 45, half of 90, 45, if I can mark here. So I'm marking 45 on this side. And from line of symmetry, okay, for sometimes what happens, instead of roller scale, if I mark 45 on both the sides, I may get some accuracy. So here, if you join both the lines, now line of symmetry you may draw by a continuous line also. So let me draw a continuous line like this. So I hope that all of you can see this line. This is the line of symmetry. Now our first job is to draw two semicircles of radius 15 and radius 22 dark. Remember, object lines are always dark. So we need to draw both them dark. So open up the compass. Okay, so once the compass is done, now there is one more way to set radius 22. So I need 22 at the bottom. So the bottom edge is 22 millimeter. So by compass, or sorry, by scale, you can directly mark 22 on the line of symmetry, and you need 15 from here. So you can mark 15 directly over here. So for this, now further, let us darken this semicircle of radius 22. So see, when you use a compass, you need to double trace left to right and right to left. Okay, so by this you will get a dark semicircle, as you can see here. So radius 22 semicircle is ready. Now for radius 15, you need to align this with the topmost point of the box, and from here we can draw a dark semicircle of radius 15, smaller than the earlier one. Okay, so little bit of I'll erase a bit. Okay, so now both the semicircles are ready. Now moving on with the question, let us carefully try to analyze. So I will zoom a bit. And now if you look at the question over here, once the semicircle is drawn, you need to move out. The shoulders needs to be drawn. These are the shoulders. The shoulders needs to be drawn. You need to come out by 50 millimeter. Okay, so the shoulders has to come out by 50, and the bottom edge is fully darkened till 90. You can see that thoroughly. And from this edge, you need to move up by a distance of 10 mm. So let us first get the shoulders out. Okay, by 50. So from line of symmetry, it is how much? 25 right, 25 left. And we will draw the extensions of 10 millimeter on both the sides. So coming back here, yeah, so proceeding further, as I told, we need to darken these two edges. It can be seen fully dark. Plus we need to raise up by 10 millimeter on either sides. So always try to double trace the lines so as to get uniform darkness. Okay, now from both the sides you can see shoulders. The shoulders need to come out by total width of 50 mm, 50. So let us draw both the shoulders out by total 50 mm. So from line of symmetry it is 25 on either sides. So let me get this aligned, pull down till the center, mark 25, 10, 20, 25. Okay, so up till here I need to darken. So the shoulders are extended till 25 mm on either sides. Even on this side, 10, 20 and 25. So I need to darken till here. The extra curve what has been come down, we need to erase a bit. Okay, so let us darken this once again, and even this one. Yeah, so once these shoulders have come out, let us go back to the question. So in the question, after these shoulders are out, we need to draw inclined line okay, then a horizontal line and then vertical. So we need to connect like this. So here also if you observe, this edge needs to be connected. You need to go down, move out and then draw inclined. So if you're ready with one side, easily you can draw the other side also. So let us try to search for the dimensions of this question. So you can see that from this shoulder, if I need to come down, this is the length I need to know. And from the question, that height is 70, what is given. This is 70, what is given from bottom to top, and this is 40. So 70 minus 40 is 30. So this height is nothing but 30 millimeter. So from the shoulder, I need to come down by 30, and then I need to form a small shoulder again. That is, I need to go out. Out by how much? So you can see that this dimension is 60 and this is 50. So 60 minus 50 divided by 2 is 5 millimeter on either side. So once you come down by 30, you have to move out by 5 on either side to get the shoulder, and then you can join the inclined. So let us follow this technique here. So from here, let me come down by 30, 10, 20, 30. I will double trace it. Even this, we will double trace it. Then we need to move out by 5 millimeter on either sides. So from here 5 millimeter I will move out. Here also 5 millimeter I will move out. And then finally I will connect this. And on this side also I will connect it like this. So the exterior surface of the front view is ready. So that is what you can see here. The exterior part of the front view is ready. What is left is we need to draw the hidden surfaces within this object. So one of the hidden surface we have discussed at the beginning, that this arc of the sector cannot be seen from the front, and that is 8 millimeter down. So from this semicircle, if I come down by 8 and if I draw a hidden line, you will get that arc of the sector. Apart from this, can you recognize two more hidden lines? Yes, so you can see that there is an L-shaped cutout. See this? There is an L-shaped cutout over here. Can you see that? So this L-shaped cutout cannot be seen from the front. And if you look at the depth of it, it is 6 millimeter deep. And 45 mm you have to go down. So if you mark 6 from here and come down by 45, you can draw a hidden line like this, right? So this hidden line is 6 mm inside and 45 mm it comes down. Then you cannot see this edge which cuts the inclined. So the length is not specified, but it is understood that it cuts the inclined. So from here you need to draw perpendicular to cut the inclined. So automatically this L-shaped surface, it resembles this hidden part. So let us draw this three, and this hidden line is on both the sides because of the symmetrical nature of the object. This is on both the sides. To total there are three hidden lines, 1, 2 and third is this arc of the sector. So let us try to draw them. So the first one is 8 mm from above. If we draw a horizontal line to cut the circle, we will get one of them. So let us start now. So from here, from the top, if I mark 8 millimeter, and if I draw a neat hidden line, all of you remember the nature of hidden line, right? It should be double traced. Darkness should be same as the object line. Length should be more, gap should be less. And it should compulsory touch the ends of the object line. So that is how a hidden line is drawn. So this hidden surface implies the arc of the sector which is behind. Now apart from this arc of the sector, you cannot see this L-shaped surface, for which you have to move 6 inside and then go down by 45. Okay, so this 6 millimeter you have to move inside and then you have to go down by 45 to get that inclined surface. not incline, sorry, to get this L-shaped surface, and it is on both the side. So over here, from this shoulder, you need to move in by 6. So let me mark 6 millimeter. On one side or both the side? Yes, it's on both the side because of symmetrical nature of the object. Now once you mark that 6 from here, you need to roll inside and come down by 45. So let me mark 45. Yeah, so this is 45, and same 45 I need to mark on other side also. So I'll mark same 45 here also. Now I just need to draw this inclined L shape. So from here we will double trace neatly. We will double trace and draw inclined on both the sides. So see, one part is ready. Same on the other side also. So you should remember that the corner should form a proper L shape. At both the ends, corner should form a proper L shape. So before we could say that the front view is over, the only thing left is wherever you find a semicircle, you need to mark a medium dark plus sign and draw center lines extending on all the 4 sides. See here, you should leave a gap to make out the difference between object line and imaginary line. You should leave a small gap on both the sides. And here you just need to draw a semicircle, extend a center line extending the semicircle. Over here also you should mark a medium dark plus sign, and then you should extend this so that is how the front view is done. See, there is no need to draw center line in the middle, because by mistake if you draw center line here, it will represent that this part is also a curved surface. So only the above part is curved, and there is a cavity, semicircular cavity at the bottom, for which we are drawing the center lines. So this is the end of the complete front view of the object. So let us start with the top view of this semicircular portion. We have already seen this. Let us see once again. So when you look at the semicircular surface from the top view, you can see first of all a rectangle. Okay, I hope it is clear. This is the rectangle, outer one. Apart from that, you can also see a flat surface in the middle, which resembles one more separate rectangle. It's a separate rectangle. Okay. So this resembles a separate rectangle like this. So between both the rectangles, this small surface between both the rectangle is this curved surface. So in a top view, this curved surface will be seen a bit apparent. Apparent means reduced. So this length will be smaller than this actual length. The actual curved length is greater, but this length is a bit smaller because of the projected nature. So that is how the top view of the cylinder looks like. What we need to complete it first. So always try to complete a difficult task, that is the curved surface first, then you can draw the flat surface. So to start with the top view, this semicircular surface, I need to start with this. So observer is looking from above. So if you look from above, this semicircular surface is the first thing what can be seen. Okay, so by means of this roller scale, I'll align with the center line of symmetry, and now okay, let me align again, and I will project the starting and ending point of the semicircle. So semicircle starts from here, it ends here. So both the points I will project down. So let me project this down, first and second. So you need to draw step by step systematically to understand orthographics. So say I projected 2 lines down. Okay, now as we discussed that in the top view this semicircular edge will be seen as a straight line. Even this will be seen as a straight line. So it's a rectangle altogether. What you need to close of width 50. See, this width is how much? It is equal to 50. And the length of this rectangle will be equal to diameter of the semicircle, that is double of 1530. So it's a rectangle of 30 by 50. Okay, so and in this diagram you can see that this length is 30 because you are projected from here itself, and this width is 50. So we need to darken that rectangle of 30 by 50. So we need to double trace it. So let us start drawing. Yeah, so once this rectangle is ready, of 30 by 50, and if you go back to the question, apart from the outer semicircular surface, you can also see the inner flat surface. Let me call it as A. So we need to draw this surface A, which is a flat surface. And to draw this flat surface, you need the length of this rectangle, which is not given. And this width we need to know, that is given as 20. So 20 is the width of the slot, and you have to leave 15 from here. So leaving 15 from here, the in between gap is 20. So one dimension is 20 is known, but the other dimension you need to find out. So if you look thoroughly, the length of this line is same as the hidden line what we had drawn before in the front view, if you can recollect. So this hidden line is same as this edge, right? See, both are same. So this edge you have already drawn in the front view, and if you can project these two edge, you will get this width, or this length you will get, sorry, this is the length because it is parallel to 90. So you get the length of this surface A, and width is nothing but you have to leave 15 and then 20. So in the front view, if you look at this hidden line what you drawn before, this hidden line cuts the semicircle at a point little bit inside the diameter. So this is the diameter which is wider, this is little bit smaller. So from here, if I align and draw a parallel line in and out both the sides, you will get two parallel lines like this. See, it is a bit inside, and you have to leave 15 from bottom and then 20. So as per the question, you need to leave 15 and then 20. Okay, you need to leave 15 and then 20. So let us do that. So I will leave 15 from here. So see, from bottom we will leave 15 and then 20. Okay, or in other words, you can leave 15 from both the sides. And coming down, we need to darken the in between part only. Remember, only the in between part, because that is where surface A lies. So the in between smaller rectangle needs to be highlighted by double tracing it. So you can see that I have drawn a rectangle dark, and the gap between the two dark lines resembles a circular surface. As I told you that this surface is round, and in graphics, whenever you draw orthographic, a rectangle without an axis implies flat surface. So if you don't draw axis, the reader will feel that it's a flat surface. So therefore, aligning with the previous line and just a bit about 50, we can draw. So here we need to draw the axis line, which represents that the surface is circular. So that is how this circular surface is ready. Now once the circular surface is ready, we need to draw the flat surfaces now. So let us analyze the next part of the object. So slowly you have to move to understand orthographic. So once you have done the circular part, look at the C surface. This C shape, let us call it as flat surface number 1. Yeah, already we have drawn this as the first one. Let us now start with a new beginning. This C type is the first rectangular surface. And a bit of imagination, if you look at this flat surface from the front view, will it be seen as a line or a surface? Yes, so in the front view, along this direction, this surface number 1 will be seen as a single line. So if you're successful enough to understand where is this line in the front view drawn, you can easily draw this rectangle number 1. Yeah, apart from this rectangle number 1, can you see any more flat surfaces as you move down? So see, below 1, you can see there is a thin rectangle which is on all the 4 sides, first, second, third and fourth. So that is rectangle number 2, which is on all the 4 sides. So first is this C type, second is this rectangle. Anything else? Any more flat surface? Yes, this one is the third surface. So if you can draw this step by step, 1, 2 and then 3, then very easily you can complete the top view. So first of all, identify where is 1 in the front view, where is 2 in the front view and where is 3 in the front view. So let us try to identify one by one. So if you try to identify this 1, say the length of this 1. So in the front view, if you look at this length, it is same as the shoulder what is coming out. So the shoulder what is coming out, that is our surface number 1, what you can see here. Okay, so surface number 1 is being identified. It is the shoulder what is coming out. Now surface number 2, which is a small shoulder coming out. So in the front view, that shoulder is here. So this is surface number 2, the next shoulder what comes out. Third one is this inner edge or the inner surface what you cannot see, and the length of that edge, if you try to understand where it is, you need to search where it is, the number 3. So this third one is same as this hidden line what is being drawn here. So once you identify first, second and third, once again, first one is the shoulder coming out, second is the smaller shoulder and third is the inner edge. So first is this outer shoulder, second is this inner smaller shoulder and third is this hidden edge what is being drawn. So don't start 1, 2, 3 together, start one by one. First only think about 1. So for surface number 1, this edge you need to project from the front and that is the shoulder. So I will align from here, I will roll back and draw a light line. Now because the object is symmetrical, we will do this on both the sides. So even here we will do that. So I projected from both the sides as you can see. Now this edge needs to be darkened on all the 4 sides. So from here, this is the first edge what we darkened, this is the second one coming down, this is the third edge what we have darkened and this is the fourth one. So we have darkened all the 4 edges. Now once all the 4 edges are being darkened, okay, so little bit more, yeah. So once all the 4 edges are darkened, we go back to the question. See this edge, then you need to move inside to get an inner C. So this edge you need to understand where it is. Okay, so the dimension is not given straight away where you want. You need to search somewhere. So this edge, if you search down, it is 10 mm. So it's given here. This is same as this 10. So you need to move down by 10 from all the 4 sides. So let's move down by 10 mm from all the 4 sides. Okay, so here I come down by 10. Here you have to move up by 10. Here you have to come down by 10 again. And here you need to move up by 10. Okay, so once you have come out by 10 from all the sides, now after you come out by 10, you need to move in equal to this edge what you drawn before, that is 6 mm. You have to move in by 6. Have you drawn 6 somewhere in the front? Answer is yes, we have drawn this hidden line that was 6 mm inside, and this hidden line was also 6 mm. So when we align this here and when we project this down, we get this 6 mm over here.